So, hello everyone. Thank you for joining us today. This is a special event, so joint Ladies Who Code and Geek Nights. So it's great that we have such a big audience tonight. So we have our speaker Sarah. She's going to be talking about unearthing antipatterns in modern distributed tech stacks. So before getting on to that, we have a couple of announcements. Ladies Who Code is going to be hosting a special event for Ada Lovelace Day. It's going to be on the 20th of October, hosted at Auto Trader. So this is going to be an evening of lightning talks. For those of you who attended this year in March, these are going to be just short talks, something that inspires you. So if you're interested in speaking, please tweet to us, email, or reach out to us on our meetup group because we want to hear what you have to say. And Philippa wants to make another announcement about an event.
Hello, I'm a developer with Auto Trader, and I thought you'd like to know about an open evening we're having next week. We're having a product and technology open evening in which all the teams that work for Auto Trader are showcasing what they do, and how they do it, and the technologies within it. I have a number of flyers here to tell you how to register for this event. It's a free event, but you can register with Eventbrite, and if you search for Auto Trader in Manchester, you'll find our event coming up at the top of the list.
There will be prizes. We have prizes.
Oh no, we don't have prizes. We don't have private prizes for the public.
Oh, come on, you're promising now.
You've raised, they won't want to come now. Now you said that.
There'll be prizes. There'll be prizes.
Don't expect any prizes.
Thank you.
Yes, I'll just pass them around actually. Everybody passes them on. You can just pass them around, and I wasn't expecting quite so many to be needed. But they can, if you work for Auto Trader.
So our talk now is going to be a brief history of distributed architecture. Sarah is a senior developer at Capgemini, and she has loads of experience in application development in different stacks. And we're really looking forward to listening to her. So welcome, Sarah.
Hi there. My name's Sarah Saunders. I'm currently working at Capgemini. And this is a talk I put together for the DevOps conference this year. I wanted to preview it on the Ladies Who Code, but they were much too organised for me. The only slot I could get was after the event, so I previewed it on DevOps, and you get the real deal. It's the archaeology aspect. It's the culmination of opinions that I've collected over the 15 years that I've been working in IT. And when I started doing Java, we were writing servlets that spat out raw HTTP, and I've watched the development of JSPs and on sort of JSF and frameworks, and now back down to microservices. And it's got me thinking, kind of how technology has evolved. So that's the archaeology aspect, is looking at the brief history of technical architecture. So for an agenda, as I'm going to talk about evolution, I just want to quickly recap on the evolutionary concepts that I'm going to use in the talk. And then I want to have a quick one-slider over the history of distributed architecture, how it's got to where it is today. And then we'll go on a dinosaur hunt. I've got 5 what I consider to be dinosaur patterns to talk through, and I'll do a couple of demos to break up the PowerPoint. And then try and draw some conclusions. So it's quite a long talk. If the demos go wrong, it could go over an hour. And if I talk really fast, I can get it down to about 45 minutes. So see how we go. So to start, as I said, I wanted to talk about evolution. So what do I mean by evolution? My favourite definition is one that Douglas Adams picked up on, which is that which survives, survives. Simple as that. It's just an observation in that in a given environment, some things do better, and therefore they remain in that environment. until that environment changes. I don't want to go into depth into biological evolution. I don't know enough about it, but one of the salient points I want to bring up is that when the Victorians started studying evolution, they believed that it was convergent, that species were converging upon perfection. They used to say, man is converging upon the image of God. But then when we started studying evolution, we realized that it's not convergent, it's divergent. Species adapt to their environments, and if the environment changes, the species adapts again. We're not going to any single point. So an example to explain this is some ancestors of the seal. In the top left is a creature called the Tiktaalik that lived something like 375 million years ago. It was one of those fish that came out of the sea. It has gills, but it also has lungs, has a rib cage and quite strong flippers. So it kind of moves on land. Fast forward to the bottom picture, that's 20 million years ago, an ancestor of the seal. It's called a Pugilia or something, and it looks more like a small dog or an otter. You can see it's furry, it's definitely got legs and feet. But then forward to the modern day seal, it looks a bit more like the Tiktaalik again. It's smooth skinned and flippered once more. So the seal isn't converging on anything. It's divergent. And I think we can see the same kind of thing with technical architectures. The example that I was thinking of was the sort of micro versus monolithic kernel debate that happened in the 70s, 80s, 90s. A monolithic kernel is, well, I don't know too much about kernel architectures, but I think the idea of a monolithic kernel is it's a black box. You don't know what the operating system does underneath it, whereas a microkernel is more like the component parts exposing the underlying operating system functionality. And most of the architectures that we see today are based on a monolithic kernel, simply because at the time that these were being created, when PC hardware, evolved, there was a slightly stronger argument for a monolithic kernel. But these days, we're still seeing microkernel architectures in existence. Unix that BlackBerry uses is based on a microkernel architecture. So an example of sort of divergence, there's no benefits. Well, there may be benefits to either in certain environments, but one's not necessarily better than the other across time. So that was the concept of divergence. And the other concept that I wanted to look at from evolution is vestigial functionality. So to demonstrate this, I've got a picture of some goosebumps. I was going to use the appendix, but the pictures were horrible, and apparently the appendix has got a use. So goosebumps, what they're for, they raise the hair follicles on a mammal in order to trap a layer of hair under the fur. This seems to have a couple of purposes. It can help insulate the animal because it keeps that layer of air warm. It can make the animal look bigger to scare away predators or impress people. But none of these really work anymore for humans. We don't have enough of a big shaggy coat that we can trap hair underneath it. And yet we still have the goosebumps because there's no reason for them to unevolve. They don't cause us any difficulties, and so we don't lose them. And I believe that our technical architectures carry vestigial functionality around in them. Things that we do because we've always done. Whereas in fact, if you look at the technology stacks that we're basing these ideas on, they're no longer relevant. So those were the two concepts really, divergence and vestigial functionality that I wanted to bring out of evolution. And now a quick sort of overview of the history of technical architecture, where have we come from. And I can see two very strong drives over time. The distribution drive, we started off with one big box and you put your punch cards in and then the answer would come out the bottom. And then we moved to a kind of mainframe architecture where you still had your big box, but you had a keyboard. The advances in the input technologies allowed the keyboard to be separated from the mainframe by a cable, and then you had the green screens. And then from there we moved to kind of client-server architecture. The internet arrived, allowing our mainframe to be much further from our clients and to be divided up, and then we get layered architectures. And then with the introduction of optic fibers, Wi-Fi, these component parts have got further and further apart, and so we now have sort of microservice type architectures where we have little pieces doing one thing well and communicating amongst each other. So there's a definite distribution drive you can see over the last 15 years. And then the other drive is miniaturization. the first mainframe was probably about the size of these telephone boxes, but now your phone is about as powerful as the computer that sent Apollo to the moon. So, the miniaturization drive is another clear underlying driver that's triggered the change in our technical architectures. This appears to have died on me. It died. Interesting.
All right. Frozen.
Completely frozen, yeah.
I don't use.
Turn it up and on again.
Yeah. Try to.
Teach me not to have a match.
Yeah. Well.
I can use one laptop.
No, it will be alright, probably not. If we're starting. Example of what I can. Yeah.
So to start everything up for the demo, we'll just see how we go over time. So we were looking at the history of architecture, and the other sort of factor is why do things change? I sort of categorised the reasons for change into two rough groups, which are called physical and social, which I don't really think are the best names. But one reason that our architectures change is technical advances. They could be hardware advances. For instance, optic fibre has made a massive difference to the speed that servers can talk at and allowed, the trust in the distance and communication between servers. And then design is things like new algorithms for compression have allowed us to build the kind of architectures that we build today. Then the other aspect that I called social, so things like large companies, a famous example would be like Sony's Betamax, or again, they're doing it again with Blu-ray. If a big company pushes a particular hardware or a particular design, they can influence the market and they can influence our architectures, because if everybody's got a Galaxy phone, you can build things for a Galaxy phone, for example. Policies, laws and standards can affect our applications. There's an app called UberPop in Germany that was, it was a sort of peer-to-peer taxi app that it was banned because, I don't know, but the law stated no, you can't do that, so architectures move away from it. And we've seen it with Google Glasses in California. Places are outlawing them, preventing them from being used. So that's another aspect which is changing our architectures. And then cultural drives. By this, I'm sort of thinking of the way that a new technology takes a while to ramp up. People take a while to have trust in something, but then once they do, they want it everywhere. And there's a sudden sort of speed pickup that we've seen with things like social media recently. So in our summary, we've got our concepts of divergence and vestigial functionality. We've got the understanding that our architectures will evolve as the underlying hardware, software, and laws change. And so with those in mind, let's go on our dinosaur hunt. A likely place to dig. So the first dinosaur that I want to talk about is the singleton. By this I mean the gang of four singleton pattern. So here's a brief definition of it. I'm sure you've probably come across it before if you've done anything with object-oriented programming. The official definition, the singleton pattern ensures that only one object of a particular class is ever created. All further references to objects of the singleton class refer to the same underlying instance. And we use it everywhere. Every time you create any kind of manager, you'll probably do it as a singleton and have it spit out an instance which will do the creation. So thread pools, connection pools, configuration management, resource management, talking to legacy systems. Everyone tends to just put the singleton pattern in because they always have. So the design of it, I feel, is very sort of maps to a sort of early noughties technology stack. So you've got your static object in the heap, you've got your threads in the stack, which are referring to the one item. It's object-oriented. It has to be. The way that you implement it requires that you have an object to manage. And one of the reasons that I've sort of always wondered, why don't you ever just use a static class if you only want one of something? And the only valid reason that I've heard so far is that you might want to implement an interface, and you couldn't do that with a static class. But if you had a singleton always returning you one object, then you can implement an interface from it. But there are many problems with the singleton pattern. I put multiple CPU architecture blocker, but basically this is, you've got multiple threads, possibly across multiple CPUs, all trying to access one object. You're going to end up with contention. So if it's a message-based architecture, you just can't use it at all. And we've had this recently at Capgemini, where a library provider swore blind that they had no static data in their libraries. So we tried to put it on our ESB. There was a singleton implementation, and it just doesn't work. There is no single place in a message-based architecture that you can hold your singleton instance. It doesn't really fit with functional programming. You're creating an object, you're managing the state of an object. That doesn't fit with the functional programming guidelines, and you can't not test it as well. So it doesn't really fit in with our kind of continuous integration style setups that we have today. So I really see it as a bit of a dinosaur. There are alternatives that you could do instead of creating a singleton class. Spring does this, inversion of control. The singleton bean is not implemented using the singleton pattern, and you can use configuration to define what you want in your class rather than static data within the instance. Or you could implement it as a service. What is a singleton if it's not a microservice floating in your program? Why not just send it out to do its singleton stuff on its own? And then constructor parameters. One of the reasons that people say, oh, I need a singleton because I want to restrict my thread pool to 20. Well, just allow your developer to have the number of connections they want as a parameter. There should be a bit of trust in the developer. So I can't really see any place where I think a singleton is the only answer as a construction. And I'm stamping the singleton as a vestigial pattern. I think it dates back to, a straight stack object-oriented world that we don't necessarily work in these days. Is a dinosaur. Second likely place to dig. ORM, object relational mapping. You probably have come across this in the Java world, Hibernate, or Entity Framework in the Microsoft world. There are also ORM libraries for PHP, even for JavaScript, but not very widely used. A programming technique for converting data between inconvertible type systems in object-oriented programming languages. And when I mark this as a dinosaur, I don't mean to underestimate the power and usefulness of ORM libraries. You know, if to be able to trust an ORM system to manage the state of your objects as you happily code away on top of them is a wonderful thing. But the trouble is that it really hides complexity. And what I tend to see is your architect comes in and goes, all right, database, middle tier, we'll put our ORM in the middle, that will do all the hard work for us, then we'll just get some junior developers to build some front ends for it. And then you go in your business layer, you're throwing around your references, you're eagerly loading half of the database into memory, and then you complain about performance. But this is because you've hidden the complexity of what's actually going on from the developer. And I don't necessarily think that it's a good thing. If you didn't have the ORM layer, you'd have to think a lot more about every single data call that you were making and what you were doing with that data. And I think it would result in better code. So my solution, instead of using the ORM panel, I can see where there would be places for it, but instead of just, as architects do, whacking it in every time they see a relational database, it's to think, well, why do I need this? Have I tested the performance? Do I need the caching? Do I need the translation? And then the other thing that an ORM library disguises is the power of modern databases. You know, modern databases are practically services. They speak XML, they can speak JSON, and you're hiding all of that power if you introduce an ORM layer. I'm not saying don't do it, but I'm saying don't always do it. So I'm stamping it as a dinosaur because modern architectures are diverging towards microservices where you need to understand the low-level data transfers that you're making. You don't want to abstract that layer, and I think ORM brings it works on too big a scale for a microservice architecture. So our third dinosaur I have here, cores. I want to do a demo to show how you might come across cores in the modern day and age, which I had all set up, but now I'm just going to have to restart everything. So I don't know if you want to all go and get beer while I do this, but let's see what. Right. So the demo that I'm going to try and show, see how I get on. Imagine that I am a hip young developer of today, doing the kind of things that a hip young developer might do. Wake up in my £500,000 loft style bedsit, have a protein shake, get on my bike that's worth more than a car, cycle to the office. First thing on my list, dear hip young developer, please can you create for me a high performance, scalable, restful dinosaur management service. So, yep, probably rustled that up this morning. So the first thing I will do is get a template, probably something like TypeSafe Activator for a good list of templates. What have we got here? So if we have a look, it will tell me REST API for the CRUD operation of a widget. Perfect, that's exactly what I want. So I'll show you the code. It's given me some Scala classes using Akka and Spray. I don't know if you've come across Spray, but it makes a beautiful and really easy way to create a RESTful API, because it has these concepts of chaining together the commands. And so I can see here that it's given me a route, it's given me a path, dinosaurs, I've got get. I changed widget to dinosaurs, but that's the only thing I've changed from the template. So I've got get for all dinosaurs, I've got get for a specific dinosaur, I've got a post to create dinosaurs, I've got a put to update them, and I've got a delete. So all I had to do was rename the widget class to dinosaur, give it view dinosaur specific properties, and I'm done. So now I can go and do more hip young developer things, get down the gym, take a post-workout selfie, put it on Instagram, hashtag no filter, apparently, I don't know, I don't do these things. And then I come back in the afternoon and, dear hip young developer, thanks for that, it's great, can you now just quickly create us a front end for it? Damn, I'm going to have to quit my job as a barista in the afternoon and do that instead. But no worries, there's another template I can use. I'm going to use Angular.js. I've got an Angular seed template. It's given me some views and a model in JavaScript. So I've got here my view dinosaurs, and then in my other view here, I'm going to have a form to create dinosaurs. It comes with HTTP server, so I'm just going to have to start that up. If I can remember where it is. Sorry, I did have all this nicely set up and ready, but okay, so now if I go to that page, hopefully it'll show me my dinosaur management view. Yeah, so there's no styling on it yet. I suppose a hip young developer would go and put a Twitter bootstrap style on it, but you can see I've got a really simple search using JavaScript to filter, and I'm just going to print out my dinosaur names. Obviously, I haven't got any dinosaurs yet because I haven't created them. But I've got my create page where I can put one in. So let's try Rex or Rorus. Don't know, Jurassic, carnivorous, definitely. Go. Oh, creation failed. So if I have a look at what's actually happened there, you can see, I've got it on the slide, so I'll show you better, but you can see there's a, I'll just run it again. First thing of interest, options is the method that's been passed. My template creator in Scala didn't think to add the options HTTP method to the chain, so that's why that one has not been understood. But the interesting point here is the message at the bottom, which if I go back to my slideshow, you can see it, the same origin policy. This is the problem that we've hit. We can't load dinosaurs from our Angular.js server because there's no access control allow origin server header on the request saying that it's allowed. And this is the same origin policy. The reason that it was introduced is basically due to weaknesses in the way that browsers were built and the way that people used browsers and cookies allowed hackers to come in and send you a message saying that they were from your server when in fact they weren't. So this was, I feel, kind of hastily introduced to prevent cross-site forgery attacks. What's the problem with it? I mean, basically, the big problem for me is it's created this backwards dependency between my RESTful service and my AngularJS front end. These two shouldn't have to know anything about each other. We should have a much better security mechanism if we want to control who can access them. And this bizarre random header stuffed in the middle is not really a good modern solution for it. I'm marking cores in the same origin policy as vestigial functionality. They're things that we can do much better now. You know, we have much better ways of securing connections between websites than sticking this header in and irritating our poor developer.
I actually think of cores more as a way of switching up to the same origin policy.
Yes, yeah, you're right. I've got my terms a bit muddled up there. So cores is the thing that you have to do in order to avoid the same origin policy. Yeah. So what I would have to do to get round it, if I go back to my demo, I'd have to change my application, which unfortunately in Scala is very easy to do, because I've wrapped all of my routes within one method, so I can just do it here. So I could put respond with this, and then I'd have to put in a raw header, access control allow origin, and then my AngularJS server. So by doing that, I would be able to get my dinosaur service to work, and that's the cause bit, putting in that. So yeah, but I think it was a fix implemented in haste to try and close these doors on what was basically a weak browser cookie set of architectures, and I would therefore mark it as a vestigial functionality. Next bit of digging. SOAP. I remember when XML was new and exciting, and everyone's like, "Oh wow, you can nest structures and you can put attributes and everything." And so web service were born out of this excitement around XML, and SOAP was going to be the language that you used for cross-platform communication. We had this wonderful, big, extensible model, and different styles, specifications arrived and were perfected and moved on. I think SOAP used to stand for the Simple Object Access Protocol, but because it got so complex, they kind of dropped it and thought, no way can we ever pretend that that's what this is. But then you've got a layer of supporting technologies. WSDL to Java, Java to WSDL allows you to very easily and quickly build a web service. I've got a demo of SOAP. Again, unfortunately, it's not been set up, so I'll see how long it will take me to start it. What I'm going to do is try and get a Microsoft ASP.NET MVC application to talk to an Apache Access Java application, if I can find my various pieces. So, find Apache. This is a slightly contrived demo because the version of Apache Access that I use for it, there are more recent versions, but there are applications out there running on the version of Access I'm going to show you. And this is a real life problem that we did come across at Capgemini. So here in Microsoft World, I created a really simple MVC application somewhere. So MVC being the model view controller pattern. Yeah, so I've got my model is just a simple, like a Java Bean class. So it's just got one property, which is a dinosaur name. And then my view is my controller is gonna forward requests to my view, which is just gonna print out the dinosaur name. But where I wanna get this dinosaur name from is from this Apache Axis web service. So the supporting frameworks around SOAP that I was talking about come into play here. All I've had to do is create an interface for my class with a method. And then I have a bean. I use a web service annotation to say, this is a web service, sort it out, implement my namer, add it to Tomcat, and I just need to start it. And then that should be all I need to do. I think I'll put it on 90. So here's Apache Axis running, and under my services, here's my dinosaur namer being. Here's its WSDL. It's a SOAP service. It's all cross-platform. And so all I should need to do in the Microsoft world, I've actually already done it here, is create a service reference, which I fed it my WSDL. And so it now knows about the dinosaur namer service and can talk to it. So in my controller, I just need to call it. So no. Not sure that it's actually found it. What I might just do is re-add that service, because when it died, I don't know if I've lost the reference to it. So all I have to do, add a service reference, paste in the WSDL, should find it. Yep, all happy and cross-platform. Let's add that in. I forgot what I called it. Service reference 1, catchy name. So service reference 1, we'll have a client here. I need to get the name from the web.config file, because this is where the details of the SOAP port binding have been stored. And it's actually not put it as localhost, so I'll just change it to localhost. So then in my controller, I specify that I want to use that. And then I can just call it name of the dinosaur. And what does it need? It needs a name dinosaur parameter. Dinosaur name, and that's going to be a new node according to autocomplete, and that node has a and this is where we've run into a bit of trouble. So our Axis WSDL has defined, so it thinks for us, the node class that we should then be able to pass our XML that you can see I've defined here in, but it's gone into complete overkill with defining the class. And how on earth am I supposed, as a Microsoft developer, to figure out what on earth Apache Axis is expecting when this is the kind of API that has been provided? I can make a guess. Text content, parent node, node name, node value, maybe. And here it is where the cross-platformness has fallen down. I would go on a complete demo, but I think I'm going to run out of time. So well, the point is that Apache Axis thinks it's made something that is cross-platform, but what it's actually done is define this Java class node in a way that's completely incompatible with a Microsoft application's ability to read it. So it's not cross-platform after all. And the reason I think for this is that SOAP went from being a good idea of let's all simply communicate via XML to this monolithic solution, which is trying to be all things to all people. You know, the specifications got longer and longer. The complexity of the supporting applications has got higher and higher. Again, we've abstracted away from what we're trying to do. And we created something that doesn't actually anymore do what it was built to do. I was lucky enough to attend a talk by John Newton, who's the founder of Documentum and Alfresco, which is the modern open source version, in about 2004. And he was talking about REST and how RESTful architectures have evolved separately from SOAP because of the problems with SOAP. And that's the reason why it's RESTful, not REST. It's a paradigm for development. It's not a specification. It allows you a lot more flexibility to choose your protocols, choose the data that you send, things that SOAP started off by doing, but ended up pinning down, trying to define. And I kind of see it as, you know, REST has evolved, whereas SOAP has had this really well-meaning bunch of people writing specifications, but they've actually not created anything useful at the end of it. So the reason that I've marked SOAP as a dinosaur is, again, because we're diverging to microservices, we're going away from these monolithic solutions and towards things where we understand the smaller pieces and how they fit together. Final dinosaur is EJBs. I've been lucky enough not to have to use EJBs too much, especially not EJP2. But if you look at what they were trying to achieve when they wrote the EJB specification, persistence, transactional integrity, security, concurrency, events, asynchronous calls, team making world peace, they might as well. Each one of these is such a massive topic to try and cover, and to try and get all that into a specification for a framework and then make it usable. I don't know, you know, at what point did someone not just go, I can't even lift this anymore, no developer is going to be able to manage it. And I think, again, Spring evolved from a sort of open source world in parallel with this, and EJB3 was created, which is much more like Spring, much more lightweight, and it's kind of pulled some of the concepts from Spring across and made it a slightly more usable platform. But it's the same thing as with SOAP. We're trying to create these monolithic solutions. We're abstracting away the complexity, but what we have at the end of the day is not actually something which is particularly usable. We'll always find something it doesn't do as well. There's no way that we can try and get through all of these specification pieces. And again, I mean, the architectures that EJBs were built to work on was that kind of three-tier architecture where you had your data source and your business layer and your front end. And that's not necessarily what we're building these days. And for those reasons, again, I'm marking EJBs as a dinosaur because we have diverged to more microservice style architectures. So that was it for the dinosaur hunt. So I'll just do a few slides now on summaries and conclusions. So there's two themes that we've been looking at. We've been looking at divergence. We've been looking at the way that architectures are diverging away from these monolithic solutions, away from these people writing specifications where they've tried to predict the future and tried to say, oh yeah, well, people will probably want to do this. And it hasn't really worked. These days we're building smaller things, do one thing and do it well. Why is this? Because of changes in hardware and software. We wouldn't be able to build microservice architectures if we didn't have the better networks that we have today. And also because of these monoliths not living up to their expectations. They've reached that period of their development now where, you know, we've all seen and used EJBs and realized that, you know, there are things that they said they would do that haven't lived up to our expectations. And then the second thing that we've seen some examples was the vestigial functionality. The two types that I put here, controllable and uncontrollable. You can choose whether you want to use a singleton or not, but you can't really control the fact that the same origin policy exists in all browsers, and it will take a long time for things like that to filter through, you know, to that kind of level where browsers might change. So the controllable types, that's the human behavior. The reason that we do things that we did last time is because we're comfortable with what we did. We want to stay in the world that we know, and we don't want to have to review things. If it worked last time, let's just do it again. And then the uncontrollable side, it's slow to change these standards. That fix was put in haste, and we can now regret it at leisure. So I wanted to come up with a conclusion, and again I was thinking, should I be looking ahead? Should I be saying, right, so this is what's happened in the evolution of technical stacks so far, what next? But I think that's exactly what I shouldn't do, because that's exactly what we've been doing. We've been trying to write specifications which are future-proof, and it's not really work. It's not really work. So I think the best takeaway is just to appreciate that things will change. The architecture that you build on will change. The underlying technologies and drives and cultural drives and algorithms will change, and possibly design for disposability instead of for the future. Maybe we just need to sort of step back and think, really, how long is this piece of code going to be used for? I'm not going to bother trying to future-proof it. I'll just get it out there, and in 2 years' time, we'll reassess and do it again. So that was my takeaway. It's no big, this is tomorrow for you. Thank you for listening. Thank you for putting up with my demos. And are there any questions that you wanted to put out now?
Yeah, you were saying about how singletons are kind of a dinosaur pattern these days, because, well, I think one of your arguments was that it's not good for multi-core systems. And another one was about how you can't mock it, which seems odd, because I think you were also saying how the reason you use it instead of just using static class is because then you can press interface, so you can mock set interface and make use.
Yeah, I mean, the interface thing is, I mean, you would use a singleton like an abstract factory, wouldn't you? So, so how do you mock out an abstract factory? Yeah.
Yeah,
you just have a mock of your. Yeah, so that's
But the problem is that you've got specifically naming your code that abstract factory. So if you want to test it, then you have to use patching or something like that. Actually, it occurs to me another reason not to use a single pattern is security, because it's incompatible with some approaches to security. So it's incompatible with capabilities, for example, where you use references to control what authority things have. So if any piece of code can reference the singleton, then you're not controlling where the authority of that singleton can go in the code.
I didn't think of that.
Because if you have got, if you're arguing against using singleton on multi-core, which I do get, that does make sense. I mean, if you go to a large scale system, then would you also argue that it's best to actually write for a single core on a microservice and then interact between them, or using Hacker or something to interact between?
Possibly, yeah. I mean, if you want to expose a singleton interface from your service, that frees you up to implement it behind the scenes however you want, whatever the hardware is that you want. In that case, you wouldn't need to tie yourself down to a single core architecture. So,
yeah, it's true.
yeah, I wouldn't say that, because if you haven't designed for a single core, you've got the ability to expand.
It's not clear to me that you ever actually need to enforce the firming one of something. That seems to be the sort of underlying rationale behind the singleton pattern that isn't adequately justified.
Yeah, I think there are a number of spears that you can come up with singleton pattern with from a number of angles. I mean, and there are a number of reasons why you'll carry on using it, but yeah, it's for the debate. Is there anything else?
What new trend looks most like something that's going to become dinosaur?
I don't know. I was trying to think. What are the big trends? And I was thinking things like, lithium shortages are going to mean that batteries are more rarer. So our battery-powered devices, is that going to change in the far future? Are we going to have biological computers where you've got the cells storing the data instead of electricity. But then I thought, in fact, even if you did have a biological computer, it's not going to change the architecture that sits on it because you've still got a little 0 and 1 thing at the bottom. So yeah, I'm not really sure. That was the only route I went down, and I thought, that could be interesting. And I thought, no.
You got one?
No, no idea.
No.
JavaScript.
Oh, Docker, yeah. Once I can get my head around Docker, I'll figure out where it fits in.
JavaScript is a good one.
Yeah. Well, thank you for listening and putting up with my demos. And yeah, carry on the discussion amongst yourselves.
Thank you very much, Sarah, and thank you all for attending. As usual, if you have any feedback, any comments, please tweet to us or email or reach out to us on our Meta group, both Knights and Ladies Code. Thank you.
Yeah.